Alright, so our box is on a horizontal plane, and it experiences the force of gravity, which is mg, as well as a normal force. And our object is being pulled at an angle of 33 degrees. And we can break it down into its horizontal and vertical components. Now, the horizontal component is equal to the force, which is 22 newtons, times the cosine of the angle. And our y component is equal to 22 times the sine of the angle. And this is 18.5 newtons, and y is 12 newtons. Now let's go ahead and use our net force equation to solve for the acceleration. So the net force is the sum of all of the forces. Since the force of gravity and the normal force cancel out, we'll not consider those, and our only forces are the horizontal force, the horizontal component of our force, and the force of friction. And we've established that this is 18.5, and this is the coefficient of friction times the normal force. Now, since we're technically pulling up, the normal force is equal to the standard force of gravity, except we're just going to subtract out 12 newtons. And this is equal to about 145 newtons. So it's 18.5 minus 0.25 times 145. And this is equal to about negative 17.75. And this is equal to the mass times acceleration. So if we just divide both sides by the mass, we can get our acceleration. And the mass is 16 kilograms. So once we do that, we get about negative 1.11 meters per second squared. And this means that as soon as we stop applying the force, this will immediately decelerate. Alright, let's go ahead and solve this using the calculator. Go to forces, then go to the horizontal motion calculator, and go ahead and scroll down to acceleration. Since we don't know the net force, enter n. The mass was 16. The applied force was 22. The coefficient of friction was 0.25. We didn't know the force of friction, and there was an angle of 33 degrees. And when you calculate, you'll get approximately negative 1.11.